All right, class, so this is a ALEKS topic that's called determining the molar mass of an acid by titration. And this is it's a good topic, definitely a little bit challenging to try to think a little bit outside the box, a little different type of problem solving, which I think is really great. I'm going to do two examples of this problem in this video. So this first one, it tells us that we weigh out 0.086 grams of an unknown monoprotic acid. So when I see that unknown monoprotic acid, I'm going to write HX. That's going to indicate that we've got an acid, and we don't know what it is. So this, counter anion, we don't know what that is, but we know that it's monoprotic. There's only one hydrogen, one acidic hydrogen. Into a 250 milliliter volumetric flask and dilutes to the mark with distilled water. So what that might look like, so this is my picture of a volumetric flask. So this would be the 250 milliliter mark. We're going to put our acid in here, HX, 0.086 grams of HX, and we're going to fill it up to the mark, 250 milliliters. And then we titrate that solution with this concentration of sodium hydroxide. When the titration reaches the equivalence point, so equivalence point, that's where the moles of acid will equal the moles of base, or I've canceled out, essentially, I've neutralized the acid. He finds that he has added 23.4 milliliters of sodium hydroxide solution. So this is a titration type problem. So right away from this information, I know that I can find the moles of NaOH added. That's sort of jumping out at me, that I can pull that information out. And if I know the moles of sodium hydroxide, well, that will give me the moles of acid because we're talking about the equivalence point. And then what I'm asked for is the molar mass of the unknown acid, and the molar mass is going to be the grams of the acid divided by the moles. So I've been given the moles I've been given the grams that we've put in. So really all I need to figure out is what that number of moles is. And like I said, I can figure that out from the moles of sodium hydroxide added. So let's go ahead and do some calculations. The first thing that I would do is I would say, given this information, can I figure out the moles of sodium hydroxide added? So number one, maybe we'll just write moles NaOH added. That's going to look like this, 0.0234 liters. So make sure we convert that milliliters to liters. And then I'm going to multiply that by the concentration, 0.0700 molar. I know that molar is moles per liter. Maybe we'll put that in parentheses, moles per liter. Then my units of liters are going to cancel out. And this calculation will give us that number of moles of sodium hydroxide that we added, which is 0.001638 moles of NaOH. When I write moles of NaOH, really, that's going to be moles of OH minus as well. We can sort of think about it that way. And the reaction that we're doing is HX plus OH minus goes to H2O. That's going to be my neutralization, plus X minus. We can have that balanced chemical equation there. So I can see that's a 1-to-1 ratio between my moles of sodium hydroxide and my moles of acid, because it's a monoprotic acid. So this number of moles of OH minus is really going to equal my moles of HX, should equal 0.001638 moles of HX. Right, and that's just because it's a 1-to-1 ratio between OH minus and HX. For the other problem that I'm going to be doing, it's not going to be a 1-to-1 ratio. So we'll talk more about that on the second half of this video. Now that I have my moles of HX, well, I'm ready to solve the problem, because if I know the grams, right, that we initially put in, and I know how many moles that represented, I can solve for the grams per mole. So the grams per mole, that's just going to equal my grams, 0.086 grams, divided by this number of moles, 0.001638 moles. And that equals, in this case, 52.5 grams. We're asked to round our answer to 2 sig figs. So in this case, based off of our new rounding rules, we would actually round this to 52. We're going to round to the even value. So 52 with the decimal point, that's what ALEKS would like for this problem. Let's do one more that's a little bit more complicated. We've got an extra wrinkle in this one. Same type of setup, but now we've got a triprotic acid. So when I see triprotic acid, I'm going to write H3X. Triprotic means I've got 3 acidic protons. And I'm going to be doing that same titration with sodium hydroxide solution. So from this information, 0.110 molar, 48.4 milliliters, I can find my moles of OH minus added. And then the chemical reaction, the balanced chemical reaction, is actually going to look a little different in this case. H3X plus OH minus is going to go to H2O plus X minus, but now we need to balance this chemical equation, right? We've got H3 over here, and I've only got, I've got the wrong number of waters over here. So the easiest way to balance this is going to end up being a 3 here, and that's going to end up giving us 3 H2O molecules as well. So I'm choosing to put a 3 by the OH minus because I know that these 3 acidic protons, they need to neutralize, and they're going to neutralize with three OH minuses. So that's going to be how I balance my chemical reaction. And then from this point, now I can find my moles of OH minus added. So that's going to look like this, 0.0484 liters. So converting 48.4 milliliters to liters, times my 0.1100 molar OH minus solution. Again, I'm leaving out the sodium because I know that that's just a spectator ion in this case, right? Sodium's always going to be dissolved, it's always going to be soluble, it's always going to be a spectator. 0.005324 moles of NaOH. Now I changed my mind and put sodium there, but really this is just OH minus. Now we need to use this mole-to-mole ratio, and this is a really easy spot to make a really simple mistake, but obviously we don't want to make any mistakes, so really we should be writing out this mole-to-mole ratio. So 0.005324 moles of OH minus, and I'm going to be doing a mole-to-mole ratio to figure out how many moles, if this is my number of moles of OH minus that I put in, well, how many moles of H3X does that sort of correlate to? So it's going to be 1 mole of H3X for every 3 moles of OH minus. Doing this, flipping this is a really common mistake. Instead of dividing by 3, we're going to multiply by 3. But writing it out makes it really easy for us to see, oh yeah, moles of OH minus will cancel. I actually need to divide by 3 in this case to get 0.001775 moles of H3X. Now we're ready to finish the problem. We have our moles of H3X, we have our grams of H3X from our original problem. So the grams per mole should equal 0.174 grams divided by this number of moles, 0.001775. And I got a value of 98.0 grams per mole for this problem. Make sure you guys can see that, 98.0 grams per mole. We're asked for 3 sig figs, so we're good to go with this answer. All right.